So we have an infinite series here, 1 plus 1 over 2 to the fifth plus 1 over 3 to the fifth, and we just keep on going forever. We could write this as the sum from n equals 1 to infinity of 1 over n to the fifth power. 1 over n to the fifth power. And now you might recognize, notice when n is equal to 1, this is 1 over 1 to the fifth, that's that over there, and we could keep on going. Now you might immediately recognize this as a p-series. And a p-series has the general form of the sum going from n equals 1 to infinity of 1 over n to the p, where p is a positive value. So in this particular case, our p for this p-series is equal to 5. P is equal to 5. Now, you might already recognize under which conditions for a p-series does it converge or diverge. It's going to converge. It's going to converge when your p is greater than 1, which is clearly the case in this scenario right over here. Our p is clearly greater than 1. We would diverge if our p is greater than 0 and less than or equal to 1. This would be a divergence. So if this was like 0.9 here, or if this was a 3/4, then we would be diverging. So at least for this one, we are convergent. Let's do another one of these. All right. So here, you might again recognize this as a p-series. Let me rewrite this infinite sum. So this is the sum from n equals 1 to infinity of 1 over, let's see, we have square root of 2, square root of 3. So you could view this as 2 to the 1/2, 3 to the 1/2, 4 to the 1/2. So it's 1 over n to the 1/2. Notice, this is when n is equal to 1. 1 over 1 to the 1/2 is 1. 1 over 2 to the 1/2, well, that's this right over here. And we keep on going on and on and on. Well, in this case, we still have a p-series. We have 1 over n to some power, and that power is positive. But notice, in this case, our p falls between 0 and 1. So 1/2 is our p. So p for our p-series is equal to 1/2, and that's between 0 and 1. Remember, we're divergent when our p is greater than 0 and less than or equal to 1, which was clearly the case right over here. So this is going to be divergent.